Hello students, welcome once again to another section. Now in this section we are to find or evaluate the surface area of the object s equal to the square root of y plus x here. Then we are given a range of values s starting from root 5 all the way to 3 about the y-axis, and we are given a and that of b. So what we are going to do is to find is that we should set up, but we should not evaluate the integral. We just set up the integral but not to evaluate the integral. So in this case, let's do a. Now in the a part, right, so for a, what we are going to get is, if we are given x here being equal to the root of y plus 5, right, and so x here is just going to look like y plus 5, and you look at a, we are given the y over the x, right, the y over the x, which means that we have to make y the subject here. We get a value, then we differentiate y with respect to x here. So that is what we are doing. So we square both sides. When we square both sides, we just have x squared here being equal to y plus 5 here, and therefore y here is just x squared minus 5, right? So if this the value of y, then which means that we need the y over the x, right? So the y over the x here is just going to give us 2x here, and therefore yeah, so that will be that. Now x values were given to be root 5 here and also 3, right, with 5 here and also 3. So yeah, so what we are going to do, we just set that the x here being equal to 1 here plus, now the y over the x here is just this value, so we put it there. Then also we square it with respect to the x here. Then we further simplify this, so the x here is just going to look like we have 1 here plus 4 x squared dx, right? Now the question says we should find the surface area, right? We have to calculate the surface area. So surface area is actually given by, so the surface area is just, the surface area is equal to the integral of 2 pi x here, then also the ds we have over here. So substitute that into it, then we have the integral, right, from 3, then root 5 here, then we have 2 pi here, then we have x here. We are differentiating with respect to x, that is why we are leaving the x, right? If it were to be x here and we are differentiating with respect to y, as in the case of b, then we have to change just change the s value here, which is equal to that into that. So we'll look at that in the second section, in the when solving a b. So over here we are left with the x, and the s here is just the square root of 1 plus 4 s squared dx, right? 1 plus 4 s squared dx, and therefore that will be for your a. So that will be the surface area. Remember the question says we should not evaluate, but we should just set up and do not evaluate, so we just leave it this way. Now let's do the b part. Now in the b part we are just, so in the b part we need we have the x here being equal to the square root of 1 plus the x over the y, right, square, then also the y, right? So that is the b part. So we're given s being equal to y plus 5, and therefore we can write it this way, y plus 5 this, so then half here. So we need the x over the y, so the x here, the y here, the s over the y here will just give us half here. We have 1 over 5 here, then we subtract 1 from here, which will be negative 1 over 2. Then this can be written as just 1 over 2 y plus 5 here, then negative just 1 over 2 here. So we can write it this way, right? So what we are going to do next is just to insert that into it. So doing that, then we have 1 plus the x here is just 1 over 2, so 1 over 2, then y plus, we have half here, right, and we square this, then we have the y here. Good. Now let's simplify that. For simplifying that, we have 1 here plus 1 over 4, right, 1 over 4. Then also this root to get rid of the square root here, so we have just y plus 5. Remember, it's 1, so 1 squared is just 1, 2 squared is just 2. Then this will get rid of that and it goes away, so we have the y here. Now if we further simplify this, we are just going to get the square root as 4y here plus 5. So 4 into bracket y plus 5 here. This goes into that, we just have 4 into bracket y plus 5, right? Then also this goes into that, we just have plus 1, and therefore we are just going to get this as the square root of 4y here plus 5 for 20 plus 1 is just 21 over 4 into bracket y plus 5. Good. So since we have this, what we are going to do is we are going to write our limit, the integral limit, in terms of x, right? In terms of x. So remember, we have x here being equal to y plus 5 here squared, so that if s here is equal to 3, then which means that we have 3 here. Now we square it and we have y plus that, we have 9 here minus 5, and therefore y here is just equal to 4, right? And then also if x here is equal to so the second s was given as root 5 here, then which means that our s squared being equal to y plus 5 here is just going to be the root of 5 squared being equal to y plus 5. This gets rid of that and we have 5 equal to 5 plus that, and y here is just 5 minus 5, right, which is equal to 0. So now since we have changed the limit in each case, therefore we can so from here we just have our surface area. And know the surface area is given by the integral of what, 2 pi here, then x here, the s here, right? And our limit has now changed to what, 0 and also 4 here. So we have 4 here and also 0 here. So therefore the surface area here is just equal to, we have 4 here, 0 here, then we have 2 pi here. Now x, then also the s here is just, all right, so from here we have the s here is just 4, we have 4y plus 21 here over 4 into bracket y plus 5 here dy. But remember x is here, so we know x here is just so the surface area will be given by 4 here, 0 here, then 2 pi. X here is just the square root of y plus 5. Then also we can change some few things here. So we have the square root of 4y plus 21 here divided by, so 4 can come out of the square root as 2, then this still remains in the square root as 5, right? So we have dy here. But remember, so if this is the case, the 2 will cancel 2 and this also cancels that, and at the end of the day we have this as 4 here, 0 here, we have pi, and then also we are left with the square root of 4y plus 21 here, then we have dy here. So therefore we can conclude that the surface area here is given by square root of 4 to 0, then pi here, then 4y plus 21 dy, and that will be it. Remember, the question says we should set but we should not evaluate, so that will be for the surface area. Thank you very much for joining me in this session. I hope this session was helpful, and I will see you in the next section.